All right, Chapter 7, Test Review. So this first thing is just a chart. It's a nice handy-dandy reference chart, kind of summarizing all the properties of these shapes. So first one, opposite sides are parallel. Well, obviously, whoops. Let's see this. There we go. Obviously, a parallelogram has opposite parallel sides. A rectangle also has opposite sides parallel, along with a rhombus and a square. Okay. Now remember what a kite looks like if you use a normal standard kite. That looks more like a rhombus, sorry. Should be taller and shorter. Okay, that's a kite. Obviously, opposite sides are not parallel there. All right. A trapezoid. Okay. A trapezoid, one pair of them do. Okay. So one pair of the sides is parallel. Same thing with a isosceles trapezoid. Okay, opposite sides are congruent. Well, goes the same here. Those are pretty standard. Kite, you can see obviously not. Opposite sides, one's long, one's short. And on an isosceles trapezoid, again, one pair, specifically the legs. Okay, the legs of an isosceles trapezoid are congruent. That's it though. All right, opposite angles congruent. Again, the basic four. All right. With a kite, you do have one pair. All right, that are the same. And that's it. A diagonal forms two congruent triangles. Well, that's all of those. And this one is kind of an exception. It depends on where you do the diagonal. Okay, so obviously, if you think about it, a diagonal here does not turn it into two congruent ones, but a diagonal this way does. So there's only one diagonal, not both. On the other shapes, both diagonals would form two congruent triangles. The diagonals bisect each other. Again, the standard four. All right. And then again, only one pair of them. Okay, so in this one, it's kind of tricky. Again, I shouldn't really say one pair. One of the ones is bisected. So obviously, if you look up here on this rough sketch, obviously the long one is not cut equally. There's a short piece and a long piece, but the short one, the red one I just drew, is bisected. So I'll say the short. Okay, the short one is bisected by the other one. Okay. Diagonals are congruent. That is just on a rectangle. Okay. And the square. So the square is a rectangle. And then also on the isosceles trapezoid. Next, diagonals are perpendicular. That is on the rhombus, the square, and on a kite. That's where you get the stability for the kite. A diagonal bisects two angles. That is only on the rhombus and the square. All angles are right angles. Well, obviously that's only on a rectangle and a square. And all sides are congruent. That's only on a rhombus and a square. Okay? So that's a summary of all the properties of these shapes. Moving on. Okay, so here we are talking about this shape over here to the right, and these statements to the left. Is this enough to prove this is a parallelogram? So I'm going to be drawing and erasing a lot. So BC and AD are parallel. So BC and AD, opposite sides are parallel. And then along with AB and CD. Well, by definition, The answer is yes. Both pairs of opposite sides are parallel. Okay. Number 3, BE is equal to ED, and AE is equal to EC. Okay. Well, the answer there is, again, yes. Because if these are equal and those are equal, this is being A, the diagonals bisect each other. All right. Next, we have CD is congruent to AB. So CD is congruent to AB. And BC is parallel to AD. I just realized on number 2, I drew the lines congruent, but I didn't mark them with a triangle. Sorry about that. Okay, so this is a no. It needs to be the same pair that are parallel and congruent. All right. So if I would have marked these two parallel after marking them congruent, that would have worked. But it can't be one of each. All right. All right. Angle 2 plus 3 equals 7 plus 6. So 2 plus 3 equals 7 plus 6. Basically what that's saying is this angle equals that angle. All right. Then 1 and 8 are equal to 4 plus 5. Again, that's basically saying those two are equal. So the answer is yes, opposite angles are congruent. All right. All right, BC is congruent to AD. So this and this are congruent. And BC is parallel to AD. Well, this goes back to number 4. All right. This is a yes. One pair of sides are both congruent and parallel. Okay, very important. All right, number 7. If the following are parallelograms, find the values of each of the variables. All right, so it tells you that AE is 20 plus Y. That's this segment right here, 20 plus Y. And ED is 2Y. Well, if they're parallelograms, these are equal because the diagonals bisect each other. So in that case, we literally just say 2y is equal to 20 plus y and solve. And to solve this, we just subtract y, which gives us y equals 20. So that's easy enough. Then CB is 3x plus 6. Okay, so that's the whole diagonal. The whole diagonal here is 3x plus 6. And EB is just this part. So think about it. We have a part and the whole. Well, it takes two parts to make the whole, right? So if this is x plus 4, then that means this is x plus 4, and we know the whole thing is 3x plus 6. So what we need to do is we need to say x plus 4 plus x plus 4, or just double it. Okay, this is nothing new. We did problems like this last chapter. So 2 of those equal the whole. So then we multiply and get 2x plus 8 equals 3x plus 6. I'm going to subtract 2x from both sides. I'm going to subtract 6 from both sides. And that's going to give me x is equal to 2. So we have y equals 20 and x equals 2. On B, we know that opposite angles are equal. Okay, so we know this is 3y. And we know this is 12y. But that would not help us really do much, except we could say all these add up to 360 because a parallelogram has 360 degrees. And that's right, that is one way to go about it. But the quicker way is consecutive angles are supplementary. So 3y plus 12y equals 180. And if you think about it, if you add all those up to 360, 360 is just double of 180. And if we added them both all up, we'd be adding 2 of these and 2 of these. So it's really the same problem, just smaller numbers. So when we combine the y's, we get 15y equals 180. And we divide by 15, we get y is 12. All right, so the best name for this quadrilateral. So card. So -8, +2. That's C. -2, +4. So left 2, up 4. That's A. -1, +1. That's R. And D, -7, -1. Now, what does it look like? It looks like it's a rectangle. Okay? But we have to prove that. Right? So to prove being a rectangle, we needed to have 90-degree angles. All right? And prove it's a parallelogram. So the easiest way to do this that will solve everything is just do the slope. So we just count the slope. So let's do the slope from C to D. So slope of CD. It's going to be a fraction. So we're going to go down 1, 2, 3. Down 3 means negative. And right 1. Right? Well, we're going to do the slope of AR. So from A, we're going to go down 1, 2, 3, down 3, and again, right 1. So we know these two sides are parallel. We just proved that. Now we're going to do the slope of CA. Well, from C to A, we're going to go up 1, up 2. So up is positive, and then right 1, 2, 3, 4, 5, 6, which reduces to 1 over 3. And then we're going to do the slope of DR. So from D, we're going to go up 1, 2. Up is positive, and right 1, 2, 3, 4, 5, 6, which also reduces to 1/3. So we've proven that these two are also parallel. So we know it's a parallelogram, and the easiest way to prove it's a right angle is opposite reciprocal slopes. Well, -3 over 1 and 1 over 3 are opposite and reciprocal. So it is a rectangle because AC is parallel to DR. Whoops, DR, sorry. We know that CD is parallel to AB. And we know that AC is perpendicular to CD. We could have picked any of the sides because we know they're all perpendicular. There we go. That's it. All right, so moving on. Number 9. Get the best name for this one. So R, -5, -1. -3, +1, so left 3, up 1, -1, -1, and -3, -3. Okay, so this looks like it could be a square or a rhombus, right? Which means besides just proving angles, parallel and right angles, we are going to have to do the distance formula and slope because we need to prove if it's a rhombus, and if it's a rhombus, we also need to prove if it's a square. So this one's going to require a little bit more work, right? So we're going to do the distance formula. So we're going to do the distance of, let's say, AM first, right? So again, we start off like this. I suggest you start off by putting this every time before you fill in any numbers, just to make sure you don't accidentally screw up a negative, negative. All right, so AM. So we have, remember, this is X and this is Y. That's X, that's Y. So -3, I plop in here, minus -1. That's why this keeps you from making that mistake. And then 1, again, minus -1. So I don't have a lot of space here, so I'm going to kind of shrink down in here. So this is going to become 3 plus 1. Sorry, my bad. -3 plus 1. So that's going to be -2 squared. Plus 1 plus 1 is 2. So 2 squared. So -2 squared is the same thing as 2 squared. That's going to be 4 plus 4. So that's going to be the square root of 8. And we can just leave it like that. Okay? Actually, I'm going to probably just put it up here just to save space. Now we're going to do, let's just go around this shape. So we're going to do MS now. So MS, same thing. All right. So M and S. So -1 minus -3 and -1 again minus -3 again. So this will be nice and easy. This is going to give you the same thing. So this becomes -1 plus 3. So that's going to be 2 squared. Oh, isn't that nice? So it's going to be 2 squared plus 2 squared, which is 4 plus 4, which is radical 8. So we've proven these two sides are congruent. You can see pretty much where this is going. So we're going to do RS next. All right, same thing. So R, -5, and S, -3. -1, and again, -3. So this is going to be adding again. So -5 plus 3, again, is -2. We've seen this one before. And this becomes 3 minus 1, which is 2 squared, which again is 4 plus 4, which is radical 8. So equal. And last but not least, we know where this is going. AR is going to be A is -3 here, and R is -5, and 1 for the A, and -1 for the R. So this becomes plus 5 minus 3. Again, we're seeing that a lot. And then this is 1 plus 1, which is 2 squared. And again, we have radical 8. So we know this is at least a rhombus. But if we can prove that the slopes are opposite reciprocal, then we also know it's a square because they're 90 degrees. So this is going to be really quick. We're just going to count. So from A to M, we're going to go down 1, down 2, right 1, right 2. Right? So down 2, right 2. And from M to S, we're going to go down 2, left 2. So down 2, left 2. All right? And then from S to M, we're going to go up 2 and left 2. And from R to A, we're going to go up 2 and right 2. Well, This is -1, this is -1, this is +1, and this is +1. So we have opposite reciprocal slopes. So this is a square. Because all sides are perpendicular and opposite reciprocal slopes. All right, number 10. Find the best name for this quadrilateral. 1, 3. So we go right 1, up 3. 5, 5. We go right 5 and up 5. U, 5, but down -3. And 1, 0. That was horrible there. All right. So we have B, L, U, E. So to me and you, it looks like it's a trapezoid, and it looks like it's likely a isosceles trapezoid, but maybe not. Maybe one leg is bigger than the other. We will see. Okay, looking at it a little bit more, it looks like probably EU is longer than BC, but we'll have to do the distance formula on that. So first off, to prove it's trapezoid, we need to prove that two sides are parallel. So I'm going to look at BE, and that's a vertical line, and LU is a vertical line. So right off the bat, there's no math there. We know these are parallel. All right. And we can do the slope on BL real quickly, and that's going to be up 1, 2, right 1, 2, 3, 4. So the slope is 2/4. And you can tell this one's not going to be parallel because obviously you can see they're running into each other, but mathematically, this is going to be down 1, 2, 3, right 1, 2, 3, 4. So down 3 and right 4. So we have a negative slope. So we know it's going to be a trapezoid because we have one pair of parallel lines and one pair not parallel. What we need to prove is that BL is a different length than EU. This will not take long. We know it's a trapezoid. We're just trying to prove it's not isosceles. So BL, so that's going to be 1 and 5 and 3 and 5. So 1 minus 5 is -4 squared. And 3 minus 5 is -2 squared. So that's 16 plus 4. That's the square root of 20. EU. So we have 5 and 1 and -3 and 0. So that gives me 5 minus 1 is 4 squared. And -3 minus 0 is -3 squared. So 4 squared is 16, 3 squared is 9. That's the square root of 25. They are not equal. So we know this is a trapezoid. All right. We have one pair of parallel lines. We have one pair of non-parallel lines. And the legs are not congruent. All right, fun continues. Number 11, find the best name for this quadrilateral. -5, 4. So left 5, up 4. 0, 6, just straight up 6. 4, 4, right 4 and up 4. And -1, +2. Whoops, that is the wrong spot. That's 1, 2. I need -1, +2. Okay. So, what is that? Well, let's do the slopes first, just to get that out of the way. So we have M, ATH. So the slope of MA is up 1, 2. Right? Up 1, 2, and then right 1, 2, 3, 4. So 2/4, which is 1/2. Let's go and do the opposite side, assuming it might be parallel. TH. So from H, we're going to go up 1, up 2, and right 1, 2, 3, 4, 5. Did I miscount? I did miscount on MA. Sorry. 1, 2, 1, 2, 3, 4, 5. I miscounted. My mistake. It happens. So it is 2/5 and 2/5. Okay. This proves math is hard. All right. So how about this one? The slope of AT. We're going to go down 1, down 2, down 2, and then right 1, 2, 3, 4. There we have negative 1/2. And now we're going to do the slope of MH. And that's going to be down 1, 2 again, and right 1, 2, 3, 4. All right, so we know that this is parallel to this, and this is parallel to this. So we at least have a parallelogram, all right? We know it does not have right angles, okay? You can clearly see that. But we're going to, and you can see that because we don't have opposite reciprocal slopes. So the only last thing to do is, actually I lied, we don't have to do anything more. This is just a parallelogram. So both pairs of opposite sides are parallel, okay? And not opposite reciprocal. That's it. That's enough to prove it. It's just a parallelogram. Okay, so 16 to 18. Numbers are wrong. Don't worry about that, please. Name the median. Oh, the median is JK. No, seriously, it is JK, right? It is this line. You know it's the median because this is the midpoint because those two are the same and those two are the same, right? So it splits those two legs into equal pieces, right? It bisects the legs. What two segments would have to be congruent for EFGH to be an isosceles trapezoid? And that would be HE and GF, the legs. The length of the median is, so the median is basically averaging the bases. So HG plus EF divided by 2. All right. So here it says EF is 2x plus 3. HG is 12. And this, again, is the median. So let's do the math. HG, which is 12, plus EF, which is 2x plus 3, divided by 2 equals the median. The median is 2x minus 4. Now, we can clean up the left side. That's going to be 2x plus 15 over 2 equals 2x minus 4. Now, we need to get rid of this 2 on the left side, and the only way we can do that is by multiplication. I use parentheses to make sure, one, that I just clean up the left side, and also that I distribute the 2 to both of these items. So what I end up with is 2x plus 15. You do not multiply the 2 by the top. The 2 is canceled by the bottom on the left side. That was the whole point of multiplying by 2. But over here, we're going to get 4x minus 8. Not 4, 8. I'm going to subtract 2x. Keep my x's positive, which means I'm going to add 8, which is going to give me 2x equals 23. I divide by 2. Yes, it's okay. I got 11.5 or 11.5. We can get decimal answers. It's okay. Now, the length of JK is 2x minus 4. 2x minus 4. All right? Well, 2 times 11 is 22, plus 1 is 23, minus 4 is 19. All right. If the measure of angle E is 62, what's the measure of angle F? Well, the base angles are equal, so that's also going to be 62 degrees. G, which is a consecutive, is going to be 180 minus 62, which is 118 degrees. Okay? In a trapezoid, it's not opposite angles are equal, its base angles are equal. But still, one from each base does make 180. Okay? So it's not all consecutive angles, it's just the consecutive angles on the legs. Because obviously, if the top ones are both 118, they're not going to add to 180. So the legs, the consecutive angles on the legs are supplementary. And that's it.